Good morning, everybody. Thank you for being here on this sunny Friday in Strandlie. And thank you, Agnes Strandlie, for joining us today to tell us more about what you're doing in NTNU. So, Arne is a professor in the Department of Manufacture and Civil Engineering, and he is now standing as a scientific coordinator of the collaboration with NTNU with CERN. And you are here today to tell us more about this and how we can engage with you and with this collaboration that we have. So thank you very much for being here. The floor is yours.
Thank you very much, Mara, and thanks a lot for the invitation to give a presentation on the, let's say, on the collaboration between NTNU and CERN, and sort of look at also some examples of let's say historical and also let's say historical collaboration, and also potentially let's say current collaborations and also potential future collaboration activities. So it's going to be a mix. So I will start sharing my slides. So okay, and then I hope it will be in. So I hope it's full screen now. So
yes, perfect.
Yeah. Okay. So as usual, I plan to spend 15 to 20 minutes in the presentation, and then there will be some time for discussion and questions afterwards. So okay. So the title I call it is the NTNU CERN collaboration, history and future prospects for research and innovation. And since this is sort of the context of this talk that was sort of presented to me by Alenka is sort of a combination of research and innovation potentially. So I tried to sort of look at a bit of both aspects actually in this talk. So what about, okay, so what is CERN? Many of you know what it is, but actually it's the world's biggest laboratory for particle physics, experimental. It's a lab doing actually the intention and the constitution is to do fundamental research, and it's really the goal of the fundamental goal is actually to understand most as much as possible of the fundamental laws governing our universe. Actually, that's the main intention. So this is a law has been existing for a long time. It's, as you can see on the photo, it's located near Geneva, southwest part of Switzerland. So you can see on the right-hand side the Lac Léman, the Geneva Lake, the sort of accelerator ring. We will talk a little bit more about what it is briefly afterwards. But you can see the main facilities are close to the center of Geneva, almost touching the airport in Geneva. And on the left-hand side top is actually the Jura Mountains. So it's in between the lake and the Jura Mountains. That's the site. Most of it is underground. The tunnel is underground, and the main site is actually in the south, where you can see CERN Mera, and that's the main site actually of the lab. So just a little bit more about CERN. I mean, it was founded in 1954. Actually, it's very strong geopolitical aspect of CERN is that this was really in the aftermath of the Second World War, where a lot of the brain power in Europe had been drained to the US due to the wars. So CERN was actually one attempt from Europe to try to stop this escape of all the good brains from Europe to the States, to build up something which could be big and large enough to be attractive. It should be something related to fundamental research for peace and not for war, and it should be open. Everything should be open and not closed. So it was really a reaction, international reaction to what was happening in the two wars. So this is really some of the history behind CERN. So and then over this now more than 70 years, actually there's been quite some, say, historical innovations during these years. So I will just mention briefly a few slides about some of the most important things that have come out of CERN, which is not related to fundamental research. So for instance, the World Wide Web. This was developed at CERN in the late 80s. Actually, as it was created to facilitate collaboration between different research groups scattered all over the world. So that was sort of the main motivation behind it. And then Tim Berners-Lee realized that well, this could be used also for more than just communication between physics groups. So CERN decided actually to just make this kind of software and development free and open it up for the rest of the world. And well, you know the history after that. So that's one sort of, let's say, spin-off. Something also quite important is that a lot of medical health technology has come out of labs such as CERN and another one. So one example used currently is PET scanners for cancer diagnostics. It's based on a very fundamental physics process, annihilation of an electron and its antiparticle, the positron, to create gamma rays and facilitate very precise sort of imaging of the internal of a body. In general, also everything related to accelerated technology for radiation cancer treatment that's been developed in labs such as CERN. So the fundamental technology behind radiation treatment is actually accelerated technology developed to do fundamental research. And already in the early 90s, it was realized that you could use other particles than photons, which is the standard radiation treatment today. And there are more heavy particles like protons and even heavy ions that could be used to do the same thing in a better way, actually. So what you see now is that proton therapy, so radiation using protons instead of photons, actually it's been growing up in Europe since many years, but Norway is now pioneering the two first sites doing this now from 2025. So actually this spring, the first patients will be treated with proton therapy in Norway, in Oslo at the Radiumhospitalet and in Haukeland and in Bergen. And well, the big advantage of protons is that they deposit energy much more localized than photons. So you see this figure here that energy deposition is much more localized, and it can therefore facilitate cancer treatment on much more, let's say, critical parts, on tissue very close to say nearby tissue that you don't really want to interfere with. So that means that you can access other types of tumors than what is usually done elsewhere. So that was just some historical background on the CERN innovations. So now NTNU has never been part of the big experimental particle physics programs at CERN. There's, of historical reasons, there's not been built up as a research group on experimental particle physics at NTNU. That many sort of sister universities, technical universities in Europe have that. So these are just historical reasons behind that. We don't have time to go into that. It's an interesting story. But within technological research, there's been collaboration with CERN since decades, and I would mention actually my acting department head, Professor Geir Overen. He actually pioneered in many ways the collaboration with CERN, in the sense that he was actively involved in collaboration with research groups at CERN. He sent a lot of technical students, so year after year, a lot of collaboration on technical student level. He was there a full year as a scientific associate, and so spent time there. And actually, this model of collaboration is something that we have ramped up in more recently, after there's been a strong ramp up of the systematic collaboration with CERN. I would also mention that the School of Entrepreneurship at NTNU, more than 50 years ago already, they established what they call a screening week, where students in this master program actually spend 1 week at CERN per year to search for opportunities based on technologies at CERN, that could have the potential to become a startup. So I say one example of this, which is still a very vivid and a live company, is TIN Technologies. It was actually a direct result of this screening week back in 2012. Looking at or facilitating solutions based on open source software developed at CERN so the business model is actually to structure this kind of software or providing solutions that libraries and research data management institutions can use. So this has been very successful and popular, and I think they are now between 30 and 40 employees in this company. So that's been a very specific outcome of this screening week with this entrepreneur school. Okay, so that's sort of enough with the history, but what is actually what is happening at CERN today, and what is happening in the future, and what is now the basis for current and future collaboration with CERN. So the flagship of CERN is the Large Hadron Collider. It's the big accelerator at CERN, 27 kilometers in circumference around, well, it's more or less like a circle. It's underground. This accelerator is full of technology. It's you need actually very, very strong magnetic fields to steer the particles around a circle instead of just moving around. So charged particles need magnetic fields to bend. So you need superconducting magnets to do that, which means that you have to cool down the entire accelerating structure down to 1.9 Kelvin, which is colder than outer space, which background radiation gives a temperature of 2.7 Kelvin in outer space. This is at 1.9. So it's colder than outer space. It's the largest coal mass in the world. The beam, sort of the beam pipe where you accelerate the particles, have a vacuum which is also better than vacuum in outer space, because outer space vacuum is not good enough. So it's really an enormous amount of technological development and research needed to run these kind of very complex accelerators, as well as the detectors, sort of the sensors look around this colliding places where the particles collide, just to sense and analyze the data. It requires quite some enormous developments within technology. So the current accelerator at CERN, it produces more than 1 billion particle collisions per second, and so it's more and this happens 40 million times per second. So you have these kind of detectors at CERN are sort of like gigantic 3D cameras taking 40 million pictures per second, to let's say just be very, very simple in the explanation. But there's an enormous data rate that needs to be analyzed very quickly and very precisely. So that's it's a lot of options for let's say challenging and innovative solutions for online monitoring, control, and data analysis. And one of the, even if you're looking ahead, one of the future projects is the Future Circular Collider. It's still not decided whether this will take place, but that's the next potential big flagship with a 100-kilometer tunnel instead of 27. Ranging, well, as you can see, the LHC is looking quite small in comparison. So there are plans to carry on and do more fundamental development in years to come. So a bit briefly, so 2016, the rector Gunnar Bovim, he initiated a much more systematic collaboration with CERN. So he appointed now ex-vice rector Jørn Brolsen at NTNU in Gjøvik as the CERN coordinator for NTNU, and Jørn was doing that for 8 years, and I took over from him last year. So in this collaboration, there was first a strategic decision from the rector to announce 8 joint PhD positions back in 2019. And there's just recently, last autumn, there was a new round of 4 new positions. And I can also say that in addition to this kind of joint PhD positions, we have about 10 technical students from NTNU at CERN at any time, from different groups scattered at least over Trondheim and Gjøvik. And I would say some of these projects have really led to a long-term research collaboration. It's been sort of seed funding to establish more, let's say lasting collaborations. This is just a list of the first 8 projects. I will not go into details of those. And then this just some kind of overview of this first round collaboration PhD project between the 2 institutions, where you see groups at CERN and environments at NTNU, and those in red, sort of that's my sort of interpretation of those groups, which have really become or have entered into a long-term collaboration with CERN. And one of them is belonging or is connected to the Ivy faculty with cooling technology with Armin Hafner. So and then these new projects, they were announced last autumn, so these are in the process of being filled. 2 of them will start up at beginning of April. 1 of them will start up in June, and 1 later this year. So Armin Hafner has 2 of these, and actually myself, I am head of one of these new. So out of 4 actually of these second round projects, 3 of them belong to the Ivy faculty. So. And just an example then of potential future collaborations on these PhD projects of Armin in cooling technology. They relate to what is happening at the LHC, but Armin also has plans for potential new projects with CERN for the FCC project, this Future Circular Collider. There's an option to use CO2 as a sort of as a mediator of taking excess energy, heat from cooling of this big accelerator, and use it for let's say for the societies around, for the benefit and for an environmental friendly use of heat excess. So that's just an example of potential future collaboration. So if you would like to know more about this, you should contact Armin directly and here if you're interested. So I can also say that we are, and time is running fast. I will wrap up in a few minutes. So there's the research related to CERN is actually now connected to a big research center financed by the Research Council called NordCC. So that's all kind of CERN related research is connected to that. And one of the activities in this center is on technology, and we are heading that, and I'm actually in charge of that activity as my due to this role I have for NTNU. And we also have Svenung Løseth as the Vice Dean of Research. She's representing NTNU in the board of this center. And as I say, due to this kind of collaboration between technological environments and let's say more physics environments, we decided to go together and apply. They're sending an application to one of these national AI centers. This is still in process, but the main idea is actually to create a center which is sort of a bridge between what is happening at CERN on a lot of really advanced AI application development. So CERN is not developing AI as such, but it's a very advanced user of AI and further development of AI. And we have ideas of how to create a center that could actually take or bridge some of this knowledge and connect it with the real applications in the Norwegian society. So we have identified quite a number of those in this application. So this is a big joint effort between the physics CERN community and NTNU. So one example of a potential of one of the cases actually in this application is to connect the next generation of so triggering, so which means data analysis at the nanosecond level using AI. This is a big project at CERN called Next Generation Triggers, which is financed actually privately for $50 million over for 4 years. And to connect this to one of, say, a very, very specific societal problem in Norway, which is the challenge that Statnett has in monitoring the future Norwegian electrical grid, where we have a lot of different types of energy sources like solar and wind connected to the grids, which gives challenges completely different from today. So Statnett actually needs to monitor the grid to millisecond or even maybe microsecond level, and has these challenges are very, very similar to what CERN actually is dealing with every single day in their kind of data analysis. So we try to couple this in. That's one of the tasks that we have identified in this central application. So, and last slide, and this is maybe a bit far-fetched, but just to see what are the options, what are the possibilities in the future. So quantum technology is something which now so there's an emerging interest, and in the Norwegian Society and Research Council has started to allocate some funding also to that. CERN is quite strongly involved in quantum technology. There's been over many years, actually, or several years, there's a large quantum technology initiative where CERN is not a fundamental developer of quantum algorithms or let's say quantum science, but to be a platform, a lab for a very, very advanced development and application development of quantum technology. As you see, then you could see just on the slides, on the pictures, like just some snapshots of current projects. So we, since we are in collaboration with this institution, I mean, there are obvious opportunities also for environment at our faculty to look at, are there innovative application areas for quantum technology that can be used in the Norwegian society in the years to come. And that's connecting to a lab like CERN, where actually they are looking at developments of applications of this. There are obvious opportunities if we just would like to grab them. So, okay, that was a bit more than 20 minutes, but thanks a lot. I will stop now and stop sharing my slides.
Great. Thank you very much for your presentation. It's very interesting to see how we are doing our collaboration with CERN, and it's interesting to see that, yeah, like you said, after many years of not having a clear collaboration, at one point it was established, and now you have you. So I want to see if there are questions from the people here. If you have any questions, just raise your hand. We'll give you the floor.